Hello, my name is Logan Murphy, and for this video, we're going to be covering how to build your own game framework. We're going to be building it using Typescript and the HTML5 Canvas API. By the end of this video, you should have a complete working version of Pong, and you should understand how to implement simple drawing techniques, entity updates, collision detection and resolution, user input, and AI. Let's take a look at our Pong game configuration. You will notice that we split the game into two layers. One for all of the text, and the other for the rectangles. Let's take a closer look at the scores. All scores are filled in with white and 10 pixels from the top of the screen. Player 1's score is 10 pixels from the left of the screen, while Player 2's score is right aligned and 10 pixels from the right. Both the scores update their text to display their current respective game score. Both scores are text entities, so let's find out what that means. Text entities simply store their configuration along with a draw function. This draw function fills the text using the given configuration. Now, let's see how we configure the goals. Both goals span the height of the entire screen and are 10 pixels wide. Player 1's goal is to the left of the screen, while Player 2's is to the right. We use an anchor to determine where to place an entity relative to its own position. The value 1 here means to position the goal relative to its right-hand side. Goals have an entity type of rectangle. Let's see what that means. Again, rectangles simply copy their configuration along with a draw function. The draw function here fills the rect with the configured fill color. Next up are the paddles. Both paddles are filled in white and are initially vertically center aligned, taking up a quarter of the screen height. Player 1's paddle is 10 pixels from the left of the screen, while Player 2's is 10 pixels from the right. Each paddle has its own movement logic, so let's see what they both do. The follow function is a computer brain that finds the center of both entities and sets the velocity to match the difference. Vertical move and stop both listen to user keys up and down, setting the velocity accordingly. The paddles also have collision reactions, which we should take a look at now. We handle collision one coordinate at a time. Depending on which coordinate causes a collision, there's a different reaction. For bounce, the coordinate that caused the collision will reverse its velocity, while stop will no longer move. Next up are the walls. The walls both take up the width of the screen and are 10 pixels tall. The top wall is 30 pixels from the top of the screen to make space for the scores. The bottom screen is 30 pixels from the bottom of the screen to match. At last, we have the configuration of the ball. The ball is placed at the center of the screen initially. It starts by moving down and towards Player 2. It will bounce off any walls and paddles. When a goal is scored, it will reset its position and go in the opposite direction. Next, we take this configuration and pass it to the library game function. Here, we pass our Pong game as a scene and set it as our default scene. We also set the state, debug mode, and background. Our state is only good for tracking the scores of the players in our Pong game for now. Now, we can call start using an appropriate output helper. We use browser output as a wrapper of the HTML canvas in context. It handles aspect ratios and allows us to interface with the drawing surface. We can also listen to events necessary to make our game more interactive. We write it this way so that we can add support for other systems like Android and iOS in the future. Now, it's time to look at our game handler. First, we initialize it with some helpers to find nodes and trigger their events. Then, we register it as an event listener of the output helper. Here, we simply handle each event as they come in and process them with the appropriate entities. Now, let's see how we handle updates in our process function. When we update, we go through each entity in our scene. We call its update event if it has one, then we process updates, one coordinate at a time. For each coordinate update, we check for collisions. If we find any, we resolve it and alert any appropriate entities. We created helper functions that easily make and check rectangles. The last thing we will look at is the draw function. We start off by clearing the screen. Then, going through each entity in the scene. We draw the entity along with debugging visuals like the outline, the anchor, and the velocity. Finally, we output the frames per second.